Okay, welcome along, guys. We're just carrying on here with exercise 9E. This is question 6 we're going to do on page 177. It says a meter stick rests on the edge of a fish tank which contains water. 30 centimeters of the stick is underwater and 20 centimeters is beyond the point of contact up here with P. If the edge of the tank is shown. Show why the reaction here at P must be vertical. Find the relative density of the meter stick and find also the magnitude of the reaction in terms of W, the weight of the meter stick. Okay, so here's our meter stick here. Something similar to what we did before with the L's. If I know that this distance is 30, I suppose I'm going to call this angle here theta. Okay. So I'll just redraw it up here. Oh, yeah. Anyway, that angle there is theta. So if that distance is 30, this becomes 30 cos theta. Okay, 30 cos theta. This distance here is 50, so this distance will be 50 cos theta. And this distance of 20 will be 20 cos theta. And no more than our L's, those cos thetas are going to cancel later on. So you can nearly just say 30 units, 50 units and 20 units if you want to. In terms of the forces acting here, the first question is, why does this force need to be vertical? Well, the forces acting are this 20 centimeter section of meter stick is 2/10 or 0.2 times the weight. This 50 centimeter section is 0.5 times the weight, and this 30 centimeter section is 3/10 or 0.3 times the weight. The only other force acting, aside from the reaction up here, is the buoyancy in the water. Okay, so the buoyancy is given by 0.3 W times the relative density of water is 1 divided by the relative density of the meter stick, which is unknown. So the reason the other force here has to be vertical is because if it wasn't, this wouldn't be a statics problem. You'd have an unbalanced external force, which means something would move. Okay, so if this is stationary, then that has to be a vertical force. Right, so let's do our forces up equal forces down. We know that buoyancy plus reaction, so buoyancy is 0.3 W over S, plus the reacting force equals 0.3 plus 0.5 plus 0.2 adds up to W, the full weight downwards. So there's up equals down. Moments I'm going to take around this point here. Now, I should have marked in this distance here. So that's the 15 centimeter point on the meter stick. And that's the, well, I suppose that's 15 centimeters here. And that's another 25 centimeters there. So that makes 40 cos 30, or 40 cos theta is that perpendicular distance. This one here is 25 cos theta. And what I'm really interested here is in 10 cos theta, not that full 20 cos theta. So I had the wrong distances marked there, but same principle. So moments about this point here. Well, my initial force in a clockwise direction, 0.5 W times my distance there is 40 cos theta. Okay, the only other clockwise force is this one, plus 0.2 W, which is a distance of 10 plus 25 plus 40 from my fulcrum. So that's 65, 75 cos theta. Okay, so that will equal my reacting force times its perpendicular distance, which is 40 plus 25 is 65 cos theta. Okay, and straight away those cos thetas cancel, just like our L's did in question 3. So what are we left with? 20W plus 75 by 0.2 is 7.5 times 2 is 15W equals 65R. Okay, so that means 35W is 65R, and our reacting force in terms of the weight is 35W over 65, which has a common factor of 5, so that's 7W over 13. That's actually the last thing they asked for, the magnitude of R in terms of the weight of the stick. But let's come back and find out what S is. We can now replace R. It doesn't matter which way you do these, you know, there's always one thing that has to be found and then the other. But this equation here is going to become 0.3W over S plus my reacting force of 7W over 13 equals my total weight W. You see straight away there, W's cancel, and 1 here means 0.3 over S equals 1 minus 7/13, which is 6/13. Okay, so 0.3 over S equals 6/13. Well, cross multiplying gives us 0.3 times 13 is 3.9 equals 6S, and then dividing through, S equals 3.9 over 6, which I think will simplify. Right, let's see if we can write it as a decimal. 3.9 over 6, 0.65. Okay, so there's 4 other questions there. I'd encourage you to give them a go. Questions 1 and 2 are very similar to the examples in the book. Question 3 is done for you. Question 4, a little bit tricky. Question 5 is manageable. They're all manageable. I think we'll all do okay with them. All right, and I'll see you in the next video. Bye bye.